At a live view of Falcon 9 at Space Launch Complex 40, awaiting liftoff currently scheduled at 7:08 p.m. Eastern Time. My name is Andy Tran, and I'm a quality engineer here at SpaceX's headquarters in Hawthorne, California. I'll be your host for SpaceX's 172nd overall launch and the 34th launch of this year. Our webcast today will cover the KPLO mission, or Korea Pathfinder Lunar Orbiter mission, headed to a ballistic lunar transfer orbit, which we'll get into a little bit later. For background, KPLO was given the Korean name of Danuri, which is a combination of two Korean words, Tair, which means moon, and Nurida, which means to enjoy. KPLO will also be South Korea's first lunar orbiter, and it's been in development by the Korea Aerospace Research Institute, or KARI, since 2016. On board the lunar orbiter are a total of 6 science and technology payloads from renowned organizations such as the Kyunghee University, the Korea Institute of Geoscience and Mineral Resources, the Korea Astronomy and Space Science Institute, and NASA. On today's mission, in addition to KPLO, we have another special rideshare on board. If you've been following SpaceX, you may remember that we launched a Tesla Roadster as the payload for our Falcon Heavy demonstration back in 2018. The early supporters of Tesla provided photos that were etched into a mosaic, and some were given the opportunity to put together a digital time capsule, both of which are now bolted onto the second stage. Following separation from the first stage, the second stage will continue to travel through time and space with the mosaic and time capsule. Although we may not see views of this right after the fairing separates, we'll keep an eye out for it throughout the mission and try to point it out if we do see it. For now, let's learn a little bit more about the Falcon 9 launch vehicle. Falcon 9 is a reusable 2-stage rocket designed and manufactured by SpaceX for the reliable and safe transport of people and payloads in Earth orbit and beyond. Starting from the bottom of the vehicle, we have our first stage, which is the largest part of Falcon 9. And as the name suggests, Falcon 9 has 9 Merlin or M1D engines at the bottom of the first stage, and this allows it to accelerate through the Earth's atmosphere into various orbits in space. The dark soot that you see around the lower part of the first stage are remnants from its 5 previous launches. After lifting off for the 6th time today, we'll attempt to recover our first stage again on our drone ship that you see on screen. That one is named Just Read the Instructions and is currently waiting in the Atlantic Ocean. Above the first stage, we have the black carbon fiber interstage that connects the first and second stages. The interstage has pneumatic pushers to allow the 2 stages to separate, and also houses the Merlin vacuum engine on the second stage that will take our payload into its desired orbit. At the very top of Falcon 9, we have the payload fairing. It is made up of 2 carbon fiber pieces that come together to encapsulate the KPLO payload and protects it until we reach the vacuum of space. Once in space, the 2 pieces will separate from each other and begin their journey back to Earth. Similar to our first stage, we'll also recover the fairing halves to fly again in the future. So that was a little bit about Falcon 9, our launch vehicle. Now let's learn more about the mission at hand and the payload flying on board Falcon 9 today.
KPLO is an acronym for Korea Pathfinder Lunar Orbiter, and its Korean name is Danuri. It is South Korea's first lunar orbiter and has been developed since 2016. It will be launched in early August 2022. It has a total of 6 science and technology payloads and will travel in BLT orbit for about 4.5 months to reach the moon, and then enter the lunar mission orbit at the end of December 2022.
Total mass of Danuri is 678 kilograms. After launch, 2 solar panels, a high-gain antenna, and a magnetometer are deployed for flight configuration in space. Total 6 payloads are equipped in the Danuri: Lunar Terrain Imager, LUTI, Wide-Angle Polarimetric Camera, POLCAM, Gamma Ray Spectrometer, KGRS, Magnetometer, KMAG, Delay Tolerant Network, DTNPL, Permanent Shadow Region Camera from NASA, ShadowCam. Danuri is launched toward the Sun, not the Moon. It will travel for about a month as the Sun gravity pulls it. Finally, it will reach around the L1 Lagrange point, which is the point of equilibrium under the influence of the Sun and the Earth's gravity. After that, when the TCM burn is started to make sure it can reach the Moon on the desired date, it will be pulled by the gravitational force of the Earth, the Moon, and the Sun to travel several million kilometers. Then, it will naturally approach the Moon that is revolving around the Earth. After entering the lunar orbit, Danuri will maneuver several times to reduce the orbit altitude. Finally, it will reach the mission altitude of 100 kilometers in polar near-circular orbit for 6 payload missions. LUTI is a high-resolution camera that has the mission to take images of the lunar surface. PolCam is composed of 2 cameras slanted by 45 degrees each to take polarimetric images of Moon's surface. The gamma-ray spectrometer is used to make a map of 5 major elements on the entire surface of the Moon. Magnetometer is used to measure the strength of the magnetic field, which is invisible. ShadowCam will record images of the permanently shaded regions around the poles of Moon where no sunlight can reach. DTNPL will conduct the world's first communication test on the Moon.
From this time on, Korean space research and development will experience a very important turning point thanks to Danuri. It is a very significant milestone in the history of Korean space exploration. Danuri is just at the beginning. And if we are more determined and committed to technology development for space travel, we will be able to reach Mars, asteroids, and so on in the near future.
As we saw in the video, KPLO's final destination will be the Moon, or a lunar orbit to be more precise. Traditionally, if we wanted to send something to the Moon, we would launch the payload into a lunar transfer orbit or a trans-lunar injection orbit. A lunar transfer orbit has an apogee altitude of approximately 385,000 kilometers, which is roughly the distance between the Moon and the Earth. To support this type of launch, our teams would select a launch window that would allow the payload to meet the Moon when it reaches apogee, and at that point it would use its own propulsion to get into an orbit around the Moon. Although this is the fastest approach, it also requires a significant amount of fuel for the payload to get into its final orbit around the Moon. KPLO will instead be launched into a ballistic lunar transfer orbit, which will require KPLO to be launched into a much higher orbit of about 1.2 million kilometers, which is about 3 times higher than the lunar orbit we just saw. At this height, the gravitational pull from the Sun starts becoming dominant compared to that of the Earth. The payload will then fire its thrusters to put itself on a return trajectory towards Earth, and this will bring it closer to the Moon, where it will once again use its thrusters to maneuver into a lunar orbit. The ballistic lunar transfer approach takes much longer to get into the final lunar orbit, but it requires a lot less fuel from the satellite. So turning our attention back on screen, we see that the strong back, which is that gray structure next to the vehicle, it should begin to recline away from Falcon 9.
Strong back recheck in progress.
We can see on screen that it is indeed reclining to its pre-launch position. It is part of a larger structure called the Transporter Erector, also known as the TE. The TE's job is to roll the rocket out to the pad and raise it to the vertical launch position that you see on screen. It also routes the vehicle's fluids, powers, and telemetry umbilicals from the ground systems to the rocket and satellites until Falcon 9 goes on internal power and clears the pad. The strong back will continue to recline away from Falcon 9 as we get closer to T0 to provide clearance for Falcon 9 to lift off.
Stage 1 LOX load is complete.
Our team in Fleur began loading propellants at the T-minus 35-minute mark, and we are nearly full on both stages. Falcon 9's first and second stages use the same 2 propellants. We use RP1, or Rocket Propellant 1, as our fuel, and superchilled liquid oxygen, or LOX, for our oxidizer. In addition to these 2 propellants, we also use the chemical TTEB, or triethyl aluminum and triethyl borane, as an ignition source. The combination of RP1 and LOX is what makes the rocket go, but it's TTEB that sets the match to the propellant mix. So right now the weather looks like we're just a 10% chance of violating launch weather requirements. The launch vehicle, satellite, and range are all looking good for an on-time liftoff today at 7:08 p.m. Eastern Time.
Stage 2 LOX load is complete.
That call out for stage 2 LOX load complete, that means that the vehicle is fully fueled on both stages and ready for liftoff just 90 seconds from now. We're starting to see some clouds form around Falcon 9 and hearing some hissing. That is normal and expected for us at this stage in the countdown. So things continuing to look good for an on-time liftoff.
Falcon 9 is in startup.
The vehicle is in startup, which means that both stages are beginning to pressurize for liftoff.
LD is go for 2 and 24.
The launch director has given the final go. All systems are go for launch of Falcon 9 with KPLO.
T-minus 30 seconds, stand by for terminal count. Fifteen, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. And liftoff. Battery, countdown, diagonal.
Vehicles pitching downrange. Stage 1 propulsion is nominal.
Falcon 9 has successfully lifted off from Space Launch Complex 40 at Cape Canaveral Space Force Station, carrying the KPLO payload to a ballistic lunar transfer orbit. So we are beginning to throttle down the engines on the first stage to prepare for a period known as max Q. During this period, the vehicle is going to experience the highest amount of aerodynamic stresses
Vehicle
on the
supersonic.
vehicle.
Max Q.
And there was max Q. So the engines are coming back up to full power. We have 3 events coming up in quick succession in about a minute. First up is MECO, that stands for main engine cutoff, followed by stage separation, and then SES1, which stands for second engine start 1. Main engine cutoff is where the first and second stages,
Engine chill
main engine
started.
cutoff is where the 9 engines on the first stage will shut off in preparation for stage separation. That is where the first and second stages will separate from one another. The first stage will make its way back to our drone ship to attempt its 6th landing, and the second stage will continue with SES1, which is where the Merlin vacuum engine on the second stage will start up and continue to propel our KPLO satellite to its desired orbit. Those events are coming up in about 10 seconds. For now, we are enjoying some excellent views of Falcon 9 during its ascent phase.
engine cutoff.
Stage separation confirmed.
MVAC ignition.
We saw the confirmation of stage separation and the ignition of the Merlin vacuum engine on the second stage. Coming up in a few seconds, we're going to be looking for fairing deploy. Those fairing halves will separate from the top of the second stage and make their way back to Earth.
Fairing separation confirmed.
And off they come. So those two fairing halves are now falling back to Earth. Those are the fourth flight for both of these fairing halves, and we are going to be attempting to retrieve them with the help of our recovery vessel, Bob. So we're coming up on T plus
signal, Bermuda.
4 minutes into the mission. We have a couple of views on screen. On the left-hand side is a view of that first stage, continuing to make its way back to Earth. And on the right-hand side is a view of the Merlin vacuum engine. On the opposite side of that engine is the second stage and the KPLO payload. So things continuing to go smoothly after liftoff. The next major milestone for the first stage occurs around the T plus 6 minute and 50 second mark. It's going to be the first of two burns.
On nominal trajectory.
The first burn is going to be called the entry burn. This is where we will relight the center engine, engine number 9, followed by engines number 1 and 5. That way we'll have 3 M1D engines helping to slow down the first stage as it passes back into the Earth's atmosphere. The engine that you see on the right-hand side of the screen is optimized to perform in the vacuum of space. It can produce over 220,000 pounds of thrust, as opposed to the engines on the first stage, which are optimized to perform at sea level. Those can produce 190,000 pounds of thrust apiece. This view that you see on the left-hand side of the screen, that's actually inside the inner stage looking up. We mentioned those pusher rods, and that we saw a glimpse of those with that video. You can also see some action on the left-hand side of the screen. We see some bursts of white gas. That is nitrogen from our attitude control system. That, in conjunction with those hypersonic griffins that you see on screen, we see 2 of them. There's actually 4 at the top of the first stage. Those help to guide and steer and orient the first stage back to its targeted landing zone. Today it's going to be the drone ship Just Read the Instruction. So we are about 40 seconds away, or 30 seconds away from that entry burn on the first stage. Second stage continues to perform nominally.
Stage 1 FTS has safed.
Stage 1 entry burn startup.
And those engines have indeed relit. The first stage is currently slowing down before hitting the denser parts of the Earth's atmosphere. This burn is expected to last for about 30 seconds.
Stage 1 entry burn shut down.
Awesome. So that burn is in the books. We have 1 more to go on the first stage. That's a landing burn that's going to happen
Startup terminal guidance.
in about a minute. we are going to be listening here in about 20 seconds for a call out called SECO, that stands for Second Engine Cutoff 1. The engine that you see on screen will shut off its engine,
has saved.
and then shortly after that, we'll listen for a call out for a nominal orbital insertion. That means that the second stage is entering its coast phase and is exactly where we want it to be before it relights its engine a little bit later on in the mission.
MVAC shut down.
So we did see that the MVAC
Stage 1 transonic.
shut down.
Nominal orbit insertion.
And there was the call out for nominal orbital insertion. The second stage is coasting for a bit longer, and we got views back of our first stage as it attempts its sixth landing on our
Stage
drone
1
ship.
landing burn.
You can start to see the drone ship.
Stage 1 landing leg deploy.
Sometimes the video cuts out. We'll wait for confirmation of whether or not the first stage was able to land. But for now, we know that the second stage is in its coasting orbit. And there is that second stage with the Merlin vacuum engine off. And that's a view of the KPLO payload.
Expected loss of signal. Keep.
So we haven't heard confirmation of the first stage, whether it was able to land for the sixth time, but the second stage is now embarking on its coast phase between the first and second burns of the MVAC engine. After the coast phase, we'll light that MVAC engine for a second time, a bit after the T plus 34-minute mark.
Stage 1 landing confirmed.
And before we head off, we did get confirmation of the first stage landing. That is the 127th successful recovery of a Falcon 9 first stage and the 110th mission flying a rephone booster, which includes both Falcon Heavy and Falcon 9 missions. So we'll see you back here in about 20 minutes. In the meantime, enjoy the Space Tunes.
Expected loss of signal, Bermuda.
Acquisition of signal, Gabon. acquisition of signal, Malindi. Expected loss of signal, Gabon.
Welcome back to the webcast of the Falcon 9 mission carrying the KPLO payload designed and developed by KARI, or Korea Aerospace Research Institute. We're coming up on the second burn of the upper stage engine in about 30 seconds. And to recap what's happened so far in the mission, we had a smooth liftoff at 7:08 p.m. Eastern Time out of Launch Complex 40 in Cape Canaveral, Florida. The first stage, which made its sixth flight today, successfully landed on our drone ship Just Read the Instructions. So again, we are waiting for our second stage engine to reignite, and then after that, we will shut it back down for another short coast phase before deploying our KPLO payload. It doesn't look like we are going to be getting video views of the second stage, so we'll be waiting for the call out of SES-2.
Nominal orbit insertion.
So we were waiting for SES-2 and SECO-2, but we got an even better call out, which is nominal orbital insertion. So the second stage engine started up, burned for about a minute, and then shut back down. Again, we are in another coast phase, and while we wait for the payload to get closer to its final destination, we're going to pause commentary during the second coast phase, but we will come back just before payload deploy, currently scheduled to occur around the T+40 minute mark. So until then, enjoy the space tunes once again, and we'll see you back here in about 4 minutes.